Hey guys, today we are specifically looking at collisions in one dimension. That means that the objects are moving in the same directions. So we'll be analyzing conservation of momentum using two types of collisions: elastic collisions and inelastic collisions. Elastic collisions occur when objects bounce off of each other and no kinetic energy is lost. Kinetic energy as well as momentum are conserved. Kinetic energy is calculated using the following equation. Ke is kinetic energy is 1/2 mass times velocity squared. So looking at this equation, we can determine how much energy the object has before a collision and how much energy an object has after the collision and compare the two values. They should always add up to be the same total amount of energy, but that's not a new idea. Conservation of momentum does the same thing. So if we look at this little video, we see that a truck is initially moving with a momentum of 60,000 kilograms times meters per second. The car initially has a total of 0 kilograms times meters per second. Once the collision occurs, the truck slows down to about half its velocity, and the car speeds up. If you look at the momentums after the collision, the truck has 30,000 and the car has 30,000. That adds up to a total of 60,000, just like the total of the truck was 60,000 beforehand. So here's an example problem that we're going to be looking at in terms of elastic collisions. A 5 kilogram cart is traveling 20 meters per second and has a head-on collision with a 10 kilogram stationary cart. If the 5 kilogram cart has a final velocity of negative 6.67, what is the final velocity of the 10 kilogram cart? So we're going to go back to the equation that I gave in the last video. We had the mass of object 1 plus the initial velocity of object 1 plus the mass of object 2 plus the initial velocity of object 2 equals mass of object 1 times the final velocity of 1 plus mass of object 2 times final velocity number 2. Now we have these separate because the carts are separate to begin with and they separate afterwards. If they were starting together or ending together, we could be adding some of the masses together. But at this point, because they start separate and end separate, we're going to keep them separate. So mass 1 is 5 kilograms. VI1 is 20 meters per second. Mass 2 is 10 kilograms. VI2 is 0. VF1 is negative 6.67. And VF2 is our question mark. So right now we have every single variable except VF2 over here. So we have 5 times 20 plus 10 times 0 equals 5 times negative 6.67 plus 10 VF2. So this entire section can go away, and I have 100 equals negative 33.35 plus 10 VF2. Now in order to separate this out, I'm going to add a 33.35 to both sides, which is 133.35 equals 10 VF2. VF2 equals 13.335 meters per second. Now notice, since its first velocity had a negative value, that means the cart started moving in this direction, there was a collision, and then it bounced backwards. So the second cart, which started at this location, has a positive velocity because it is moving in the positive direction on the number line. The second type of collision we're going to talk about is inelastic collisions. These occur when objects stick together for at least a moment and some kinetic energy is lost. That kinetic energy transfers to sound, heat, or light energy because in a car accident, you always have some sort of output. You have sound being created. You might have heat from the friction, so that some of that kinetic energy can go someplace else. In this situation, only momentum is conserved. So most of our calculations are completely inelastic. That means that the objects stick together and they stay stuck together. So for example, with this MIDI video, as I play the video, the car travels forward, gets stuck underneath the back of the truck. Notice that the car has a momentum of 20,000 kilograms times meters per second, and the truck has 0. Once the collision occurs, the car's momentum drops down to 5,000, and the momentum of the truck is 15,000. Now, one thing I do want you to pay attention to. What relationship do both velocities have after the collision occurs? They're the same, because the objects are sticking together and moving together after the collision occurs. So the velocities at the end have to be the same value. So here's an inelastic collision example problem. A 19.5 kilogram cart travels 9.87 meters per second, has a head-on, perfectly inelastic collision with a 32 kilogram cart. The joined carts travel with a velocity of 2.77 meters per second. What is the initial velocity of the second cart? So for this example, when I write down my equation, the two carts are separate to begin with, and afterwards they are sticking together. So just like in the previous videos, I'm going to take my two masses and add them up, so I only have to do this math once. Okay, so M1 is 19.5, VI1 is 9.87, M2 is 32, VI2 is my question mark, and VF is 2.774, which I already added in this equation because the VFs are the same since they are traveling together. So I have 19.5 times 9.87 plus 32 VI2 equals 19.5 plus 32 times 2.774. 19.5 times 9.87 is 192.465 plus 32 VI2, 51.5 times 2.774. So I have 192.465 plus 32 VI2 equals 142.861. Now I have to subtract this 192, and I'm left with 32 VI2 equals negative 49.6. I'm going to divide by 32, and the initial velocity of the second cart is 1.55 meters per second in the negative direction. So if we think of the number line, the first cart is traveling this way. The second cart is traveling this way. Collision occurs. The first cart and the second cart continue moving in the positive direction because this value is a positive velocity. So once they collide, the red cart overtakes the green cart and they continue moving in the positive direction. But that negative 1.55 means this green cart was moving to the left on the number line before the collision occurred. So when we get to class tomorrow, we're going to practice with some of these problems. I know you've done similar examples, but now we are going to use the terms elastic and inelastic, so you know what type of math you have to do. Should they stay separate? Should they then combine? So I'll see you tomorrow so we can practice.